This paper tackles an important question in RAG systems. Does performance drop due to having longer context or specifically due to having multiple documents? Previous studies noted that retrieving many documents can degrade performance but didn't isolate variables. The authors created a controlled experiment using multi-hop QA tasks, keeping context length constant while varying document quantity. This helps understand whether we face a long context challenge or specifically a multi-document processing challenge.
Figure 1 illustrates their experimental design. They started with multi-hop questions that require information from 2 to 4 supporting documents, shown in pink. The original dataset had 20 documents per question. To test document quantity impact, they created variants with fewer documents, 15, 10, 8, or just the supporting docs. The key innovation, when removing documents, they extended the remaining ones with related Wikipedia content to keep the total context length identical across all variants, while preserving the position of the critical information.
The methodology involved testing 6 state-of-the-art LLMs across 3 families, Llama 3.1, Qwen 2, and Gemma 2, each in both smaller, 7.9b, and larger, 2772b parameter versions. They evaluated using F1 scores comparing predicted answers against gold standards. Beyond the main experiment, they created additional test variants to check for data contamination and to compare the effect of relevant distractors versus random distractors. All source code and datasets are being made available to support further research in multi-document. Figure 2 visualizes the central finding. When context length is fixed, most models perform worse with more documents. The x-axis shows document counts 2 to 4, 8, 10, 15, 20, while the y-axis shows F1 scores. Llama 3.1 and Gemma 2 show clear performance drops of up to 10% as document count increases. Interestingly, Qwen 2 bucked this trend, maintaining consistent performance regardless of document count. Smaller models, 7 to 9b parameters, follow similar patterns as their larger counterparts, but with less pronounced effects, suggesting the challenge affects models of all sizes. Figure 3 shows a surprising counterpoint to Figure 2. When using random Wikipedia paragraphs as distractors instead of topically related ones, performance actually improved with more documents. This reversal suggests the problem isn't simply about processing multiple documents. It's specifically about resolving conflicts between semantically similar documents. When documents are completely unrelated, models seem better able to filter irrelevant information. This finding has important implications for retrieval systems, suggesting they might benefit from increased diversity rather than retrieving many similar documents. The conclusions have important implications for RAG system design. The research clearly demonstrates that processing multiple documents presents unique challenges beyond simply handling long contexts. When retrieving documents, the quantity matters. Sometimes fewer, more comprehensive documents may be preferable to many shorter ones. Future models would benefit from specialized mechanisms to identify and resolve conflicting information across documents. The study was limited to 2 to 20 documents and specific datasets, suggesting future work should explore more document count variations and diverse datasets.